All right, so looking at function operations this time around. So we're dealing with adding them, subtracting them, multiplying them, dividing them, all that good stuff. So we're going to start with adding and subtracting. So there's a couple of different ways that they can write the notation for it. So they can write notation this way where they say f plus g of x is one way of showing it, and then the other way is to actually write f of x plus g of x. So they mean to do the same thing. You're going to do the same exact operations. It's just two different ways of writing it. Same thing with subtraction. Oh, that's a little typo. There should be a little subtraction sign in there. I apologize for that. So f minus g of x is the same as saying f of x minus g of x. So what these are saying is you're going to add the two functions together. This one is saying you're going to subtract the two functions together. So then down here, when you're doing your operations with your functions, the domain of the sum or the difference consists of the x values that are in the domains of both. So this kind of goes along with the inequalities that we were dealing with the ands and the ors. It's kind of like the and inequality. The domain would have to be able to work in both of the functions after you add them or after you subtract them. So that's kind of like an important thing to keep in mind there. So let's take a look at our first example here. We have f of x equals that, g of x equals this. So kind of looking at this one right here, this is a linear function, so I'm kind of thinking in my head, my domain is everything. X is an element of the reals. It's going to be every single real number that we have. Whereas this one being a radical, take the stuff underneath the radical, it's going to be greater than or equal to 0. So our domain for that one is going to end up being greater than or equal to 0. So what we're going to do with these two functions is we're going to take them and we're going to add them together. And then we are going to separately take them and we're going to subtract them together. So we want to do both of them. We're going to practice both adding and subtracting here with these two functions. Now you do have to go in order when you're doing your adding and subtracting. So I'm going to start with my adding one here, f plus g of x. I'm going to take the f function first, and then I'm going to add the g function to it. So my f was 7x minus 2. My g was the square root of x plus 2x. This is me adding my f plus my g here. So then I'm going to combine any and all like terms that I can combine. So I'm going to have my square root of x. 7x plus 2x gives me 9x minus 2. So then I'm just going to add my notation in there. Square root of x plus 9x minus 2. So then our domain for it, because I also asked what's our domain. Our domain for this would be x is greater than or equal to 0, because the domain from the f function could be anything. However, the g function was restricted. So we're going to end up using that restricted one. And that's what's going to be the domain after I've added them. Let's do the same thing, but subtracting now. So we're going to do f minus g of x. So again, I'm going to go in order. So that's going to be my f function first minus my g function. And I did put parentheses there on purpose because there were two terms in my g function. So I want to make sure I actually end up subtracting both of those two terms. So I'm going to end up getting the negative square root of x. This is going to become a minus 2x here. So 7x minus 2x gives me a 5x minus 2. So just bringing my notation back. F minus g of x is going to be the negative square root of x plus 5x minus 2. And then our domain yet again would be x is greater than or equal to 0. So adding or subtracting functions, you just actually add or subtract them together. These ones wanted us to leave x in there. Sometimes you might see where it's a number in there. So you can plug the number into both the functions and then add your answers together. or subtract your answers together, depending on what it is. So you just have to pay attention to what they're using. These two both wanted x's, so that's why we have x's in our answers. So next to multiplying and dividing. So again, two ways to be able to write it, f times g of x or f of x times g of x. Same thing is going to be happening here. You're going to be multiplying them together and getting your answer from that. And then here, f divided by g is the same as f of x divided by g of x. And the only restriction here is that g of x cannot equal 0 because it's in the denominator. And as we talked about before, you can't have a 0 in the denominator of your fraction. So that's why the function g of x cannot be equal to a 0. So this one, let's read our little note about the domain here. It says the domain of the product and quotient of functions consists of the x values that are the domains of both. So again, it's what's in both. But you also have to keep in mind with quotient, it cannot contain any x values that make the g of x, so the denominator function, equal to 0. We can't have that. That's not allowed. So it would be whatever's in both except when dividing, whatever makes that denominator a 0, we can't have. So let's take a look at our example. So again, I have my f of x here. This is a quadratic. This is a 2x squared here. So I'm just already thinking in my head, because we were talking about domains, that my domain for that one is everything x, e, r. And then my g of x is x minus 5. This one is a linear function. So again, domain is going to be x, e, r. There's no restrictions on our two original functions this time. So we're going to talk about that when we get to figuring out the domains. So we're going to figure out both. We're going to do f times g of x, and we're going to do f divided by g of x. So let's do our multiplying first. So f times g of x is 2x squared minus 9x minus 5 times x minus 5. Whew. This is going to be a multiplying one. We will deal more with multiplying in the future, but for now, if you recall, that means we just have to distribute everything to the other term here. So 2x squared times x is 2x cubed. 2x squared times 5 is minus 10x squared. Now I'm going to distribute my 9x. So negative 9x times x is negative 9x squared. Negative 9x times 5 is positive 45x. Now I like to line up my like terms, as you can see here. You can keep stringing them along. That's entirely your preference. So then my negative 5, I'm going to distribute that, so I get negative 5x plus 25. So combining my like terms, which there are some here, 2x cubed minus 19x squared plus 40x plus 25 is going to end up being my final answer for this one. Now this one wasn't a quotient, so that just means that our domain is going to be the domain of both. So in this case, that would be x is an element of the reals, or negative infinity to positive infinity. If you wanted to use the interval notation, we very well could use the interval notation here. So then the other one, f divided by g of x, is going to be 2x squared minus 9x minus 5 over x minus 5. Now, we have not talked about factoring yet, but in this case, what we would end up doing is we would end up factoring our numerator here. Well, I don't know what you remember as far as factoring goes. This would end up being 2x plus 1 and then x minus 5. X minus 5. I got this because 2x squared is 2x and x. The only way to get a 5 is 1 times 5. but I wanted that to match my denominator so that those could cancel out. So 2x plus 1. So for this one, for our domain, and I know I brushed through that quickly. You're not going to have factoring examples, I promise, right now. I was just going through that quickly so you could see we wanted those to cancel out. So our domain for both is x as an element of the reals. However, what value makes this a 0? It would end up being 5, so x cannot be 5. So kind of like our restricted domains that we talked about a couple days ago. All right. So I'm taking a look at our last part here, composition of functions. This is a completely new topic for us. Composition of functions. What that means is you're combining two functions together. So you're going to be taking a function and you're actually going to be plugging it into another function. We have two different kinds of notations that we end up using for it. And they are right here. There's one of them. And then here's the other one. Those mean the same thing. So what's happening is this little circle guy here, that represents the word after. So what this is saying is you're going to do the g function after you figured out the f function. So what you're going to be doing is you're going to be plugging something into your f function, taking that answer, and plugging it into the g function. This is our other way of writing it as well. So again, you would start with what's in the middle. You would evaluate that function and then plug the answer into the g function. And it can go the other way. You can do f of g of x, which can be written this way. Any functions, they can use any functions. They can use the same function twice. So you could have f of g of x, and that would work as well. So again, you evaluate the function towards the middle first, the function that is closest to your x. So in this case, this would be f. Over here, you would do your g function first, and then your answer gets plugged into the other one. Function composition is not commutative, so you can't switch the order. You do have to follow the correct order and go with the middle first and then work your way out. The domain of g of f of x consists of the x values for which f of x is in the domain of g of x. And that wording is very confusing. So we'll take a look at our examples down below and we'll talk about it. A lot of times talking about it with an example helps it make a little bit more sense. Let's take a look here. So we have f of x is x plus 7, g of x is x squared minus 1. So what they want us to do first, again, we're going to work from the middle out. We're going to find f of 3 first. So f of 3 would be 3 plus 7, excuse me, which is 10. So now I'm going to take this 10 and I'm going to use that in the g function. So I'm going to do g of 10 here. Okay. So g of 10 would be 10 squared minus 1, which is 100 minus 1, so it's going to be 99. So g of f of 3 equals a 99. Now we don't state a domain here because we got a numerical value as our answer. We state a domain when we have a variable as part of our answer. So when we have an x in our answer, that's when we would talk about what the domains are. We don't have that here, so we don't need to really worry too much about the domain of that composition. Okay. Let's try this next one. So again, I'm going to start into the middle, so I'm going to find g of negative 5 first. So that's going to be negative 5 squared minus 1, which is 25 minus 1, 24. So I'm going to take that 24, I'm going to use that in my f function. So f of 24 is 24 plus 7, which is 31. So f of g of negative 5 is 31. So you're plugging it into one function, and then you're taking that answer and you're using it in the other function. So then our last one here, instead of a number, we're going to put an a. So f of a would simply be a plus 7. And I can't simplify that down any further. That is as simplified as that's going to get. I'm going to take that and plug it into g. So what that means for g is a plus 7 is now going to get plugged in for our x. We would get a plus 7 squared plus minus 1. So you can leave it like that for now. If you choose to multiply it out and then combine your like terms, you would end up with that trinomial as your answer. But again, you can leave it here for now. So just taking what you get from one, plugging it into the other for your compositions. Adding and subtracting means you just combine them, add them or subtract them, multiply or divide them, however it is that they tell you.